Hey kiddos, let's pick up right where we left off. And what we're going to do is we're going to tie together two concepts that have kind of been floating around out there and hopefully bring some sense to some of this nonsense. I'm going to put a minutes label, so it's time in minutes on this axis. I choose this to be typing speed. I want you to know they spent a long time coming up with what these things should be when I'm thinking about them. So this would be like words per minute. And here's a squiggle wiggle that describes the words per minute that somebody can type. No numbers, they're not important right now. All right, so if I'm going to call this function, because it's a words per minute, I'm going to call it f prime because that's what you're comfortable with. You like it when rates are written as f prime, so I'm going to call it f prime. So if we come in here and we start finding the area of a rectangle that lives inside here, the units on that rectangle, the height of that would be in words per minute, and the base of that would be in minutes, and you crisscross and you just get words. So the amount of words typed, the number of words typed. So what you've just said is that when you integrate, when you find area under curve between A and B of this thing that I'm calling f prime, you get out just a function that's measured in, I'm not going to call it, it is f, that is the amount of words typed between time A, B. So this is not necessarily the total number of words typed. It's only the number of words typed in this particular interval of time. So this person, whoever it may be, was typing. You can't discount how much has already been done or what's going to come after. So it's only the amount of words typed between time A and time B. So another way of doing this, another way of writing this, if I take an integral between A and B of some function, I'm not going to put a derivative on it because I want you to start thinking of integrals as their own things. What you get out is a capital F. This stands for antiderivative. So antiderivative. So that's something we did yesterday with antiderivatives. I didn't call it big F. Maybe I did. I made that video a couple days ago. But what you get out is the antiderivative. What's different today is that we have bounds on these integrals, and so there's no plus c to put in. So if we take in this information here about how it's the amount of words typed between time A and time B, we can apply that down here and say that this thing with bounds now would be f of B minus f of A. So what's going to happen is you're going to take the antiderivative just like we did yesterday, but now you're going to evaluate it at your bounds. And you do that by plugging in the top, minus, plug in the bottom, subtract. The end. Like, that's it. This is actually the fundamental theorem of calculus. Well, I can't write theorem and talk. Of calculus. This is one of two versions of it. So we'll do the other version on the next day. But this is kind of a big deal. The fundamental theorem of calculus. So let me show you what it looks like in a question, because that's all I'm doing now is just working examples with you. Let's have just a quick polynomial in here, nothing scary because I don't have the brain power to manage this. And let's set these bounds from 0 to 3. So if I were to first take this antiderivative, just like we did in our video yesterday, I'm going to add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power. But now we're going to evaluate this from 0 to 3. So what that means is I take 3 and I replace it where all the x's are. And then I come back and I take 0 and I replace it where all the x's are. And I subtract those two values. I think I'm smart enough to do this. Let's keep going. 3 cubed is 27 divided by 3 is 9. minus 6, that whole thing's 0. I just get 3. So the change in the function between time 0 and 3 is 3. Let's do another one. Because having 0 as a bound is really friendly. Having negatives as bounds makes your little brains bleed. But we're going to do it anyway. And then let's do something. Can I? I will. How about that? So I hope you remember from yesterday that if it's not just like an adding 1, dividing by new, it must be the back of a flashcard. Well, I can pull this 3 out. I can hold on to that until later when I'm ready, because that kind of makes this part more familiar to me. This is the derivative of inverse tangent. So its antiderivative must be inverse tangent. And then there's a 3 out there. So we're going to go ahead and throw that in. Now you have options. I'm going to pull the constant out. I just don't like writing things unless I have to. I'm going to plug in the top minus, plug in the bottom. If it were a calculator question, I would type it. It's not. I'm just going to leave it. It's fine. Everything's fine. I mean, I know this. Do you know this? It's pi over 4. I don't know that one, so I'm not going to try. Let's do another one. What if you had to integrate from 4 to 1? This thing that I'm going to make this. All right, a couple things. Maybe not right now, but eventually I kind of hope that this makes you a little bit uncomfortable. Like integrating from 4 to 1 is going backwards. So remember the properties of integrals we've kind of been talking about a little bit. You can flip those bounds as long as you then flip your sign. So you can change the bounds on them. If you prefer this, that's fine. You can do that. Do you have to? No, we'll get the same thing. And here's why you're going to get the same thing. Because over here, you would take this antiderivative. You would evaluate it at 1 minus evaluate it at 4. Over here, you're going to take this antiderivative. You're going to evaluate it at 4 minus evaluate it at 1. Oh, but look, there's also a negative out there. So it's the exact same thing. It doesn't matter. I actually just kind of prefer this because I don't care about, like, I'm not doing it graphically. I don't care about the numbers being out of order because I'm just going to plug and chug. But if you remember from yesterday, you don't know how to undo a product. You're going to have to multiply this in first. So I'm going to keep it as the integral from 4 to 1. This would be x to the negative 2 and a 5x squared. And now I'm ready to go. We're going to add 1, divide by the new, throws a negative underneath or up top. We're going to add 1. We're going to divide by the new, and we're going to evaluate from 4 to 1. So if I put a 1 in, I get negative 1 to the negative 1 plus 5/3 times 1 cubed. I'm just writing it. I know we all know, but I'm writing it. Here would be a negative 4 to the negative 1, 5/3 times 4 cubed. They can get messy. They can get obnoxious. Like you can get these really terrible fractions. It's okay. Pull out that calculator that I've been asking you to use. It's fine. The AP test might have you do something this obnoxious, and that's okay because you know how, but I'm not really stressed about your arithmetic right now. I mean, it would be nice for you all to know that this is negative 1/4. So that kind of stuff I am worried about, but your actual like plugging of arithmetic, not so worried. All right, that is the first part of the fundamental theorem of calculus. We'll do part 2 in the next video. Get excited.